Hello, and welcome to the Johnson Controls Blue Water webinar for December 2022. I am Craig Hanna, and I am thankful for the opportunity to serve as the engineering manager of the Johnson Controls Water Infrastructure Technology team. Our team of subject matter experts is dedicated to designing, installing, and commissioning projects that reduce water loss, that increase water utility staff efficiency, and that decrease operational and maintenance expenditures. In short, our team exists solely to provide your water utility with the critical tools and training it needs to be a well-run organization. It's the holiday season, and I, for one, simply cannot believe that the year is almost over. And how did it go by so very quickly? It's a mystery. I do know, however, that we have a very fun and informative webinar prepared for you today. We decided to set a festive mood by wearing our ugly Christmas sweaters to the webinar, and I now want to introduce you to two of my teammates who are also wearing their ugly Christmas sweaters. Audrey, would you please tell us more about yourself and your role in this team?
Absolutely. Thanks, Greg. I'm Audrey Noel, Director of the Water Infrastructure Technology team here at Johnson Controls. I have 7 years of industry experience, a Juris Doctorate with an emphasis in environmental law, and decades of experience in operations. I have the privilege of leading the team from the sunny shores of Huntington Beach, California, but I couldn't do it without our very knowledgeable market manager, Jonathan Gunn, who offices 2,700 miles northeast of me in Canandaigua. Jonathan, tell us a little bit more about your experience, please.
Yeah, thank you, Audrey, and good morning, everybody. Again, I'm John Gunn. I'm a market manager with our water infrastructure team, and I have 13 years in the industry, and like Craig, I serve in a number of different capacities within the American Water Works Association, including as the current chair of the Customer Metering Practices Committee, and then I also co-author a number of manuals and publications, one of which has a very pertinent relationship to our webinar topic today, which I'll let Craig cover in a minute, but that would be the M36 manual, for which Craig and I are both co-authors on there. And if you're looking to put together a water audit, that's the one that's going to guide you through that process. More specifically, I'm responsible for the chapter on the occurrence and impacts of apparent water loss, and Craig is the author for the chapter on apparent water loss reduction strategies. So, but more on that a little bit later. If you've been with us for any of the past webinars over the last year, you may have noticed that this month we have switched platforms, specifically to the GoToWebinar platform, which probably looks very familiar to most of you, given how many other events and meetings use GoToWebinar. As such, from here on out, we're not going to be going through our usual overview of the platform. Our expectation is that most of you are familiar with it. If you do have any other questions or any questions, however, please do feel free to submit them in the Q&A, and we'll try to help you as best we can. I will point out that we do have some poll questions in store for you today, so be on the lookout for those. And we do also have 3 handouts which are currently available for download. Simply use that drop-down menu for the handout header there, and you'll be able to access and download that information. So with that being said, Craig, do you want to take us through the agenda for the morning?
Yeah, I'll be glad to do that, Jonathan. We'll start our webinar today with a short talk about water utility worker safety, and specifically how to be safe whenever you're forced to work in the field by yourself. We will then present a case study from a water utility here in Texas that truly tells the tale of why your utility needs to invest both the time and the effort required to compile an accurate water audit. I know that you will be amazed with the case study that we have to show you. And following that, we are so glad to have TJ Butler and Marcy Rather from GoAigua as our partner guests this month. GoAigua is a software provider that uses advanced algorithms to integrate data from all sources of existing technologies to provide a holistic, real-time view of the status of utility processes and infrastructure. And now, let's talk about water utility worker safety. I, for one, never like working in the field alone. There is always the risk that something could happen to you, such as a car wreck, aggressive dogs or other animals, people with anger management issues, or even an injury at the job site, then there would be no one there to assist. And yes, I always carry my cell phone with me and I make sure that's charged. But what happens if your cell phone is either damaged in the incident or if you simply cannot access the phone for whatever reason? I've also had to work in many large meter vaults in which there is absolutely no cellular coverage in the area. So if you find yourself working either remotely or alone, here are some very useful tips. First, plan for what you may encounter by evaluating the potential hazards. What is the weather forecast for today? Are there any severe weather threats? What are some emergencies that you may encounter in the field, such as flooded areas from either weather or a main break? Are there any downed trees or power lines that may pose a hazard to you? Is there anything at the site that could possibly create an electrical shock? Is my vehicle fully fueled for freezing conditions or if they're expected? Do I have snacks to eat, water to drink, and any necessary medications if I get stranded? Who will provide traffic control if that is needed? And can the motorist see me where I'm working? And do I have adequate lighting at the work site to do the job safely? Am I trained in first aid? Do I know how to dress a wound? Am I mentally and physically prepared for animal attacks, snakes, insect bites, and will drug needles be a risk in the area that I'm working? Is my PPE bag stocked and ready for the field? Lastly, do I have the correct tools for the task that I'm assigned, and are my tools in good condition? If you find yourself working alone, here are some other very useful tips. First, designate a key point of contact who is not also working in the field that day, and make sure that that designated point of contact is both a responsible and a trustworthy individual. Make sure that the point of contact knows who is working remotely that day and for approximately how long the work will take to complete. You need to establish regular check-in times for the entire period that someone is working alone in the field. And at each check-in time, the point of contact will document both the time and any other important information from the field worker. Make certain that the point of contact knows to relay any anticipated changes in the weather, such as storm watches and especially storm warnings. And we hope and pray that this never happens to you, but I once had an employee go missing early one morning, and I can tell you that you absolutely do not want any part of that experience. I can say thankfully she was found safe and unharmed at the end of what was a very long day for both her family and for our team. But if the person who is working alone in the field misses an established check-in time and you cannot reach them, I recommend that you first keep trying to contact that person for at least the next half hour. Contact anyone from your utility who may be working in that same area and ask them to please drive over to the site and look for the missing worker. If there's still no response from that worker, assemble a search team and direct them to the last known location. Contact 911 and describe the area in which the person was working or where the vehicle tracking device reports their location if that's available. Describe the vehicle to the best of your ability and provide a physical description of the missing worker. Once the situation has stabilized, don't forget to initiate the incident and injury reporting process if necessary. Now, I know that we've been talking about people who are working alone in the field, but many people are working remotely from home now. And I encourage you to be a good teammate and contact those who work remotely on a regular basis. Let them know that they have not been forgotten, that their contributions are truly appreciated, and that they are a valued member of your team. I realize that we are all shorthanded and our time is so very precious, but just a few minutes of your day may make a big difference to that person who is working remotely. And now it's our final webinar of the year. And like you, we are so ready for the holidays to start. Before we get started on our water audit case study, we have a fun poll question for you. And that is, who is wearing the ugliest Christmas sweater? Audrey, Jonathan, TJ, Marcy, or me? And if you will, please vote. Okay, just All right, well, let's see who won. And it looks like I have the ugliest sweater. Okay,
Is that a comment on the sweater or A&M, Craig? I don't know.
probably both.
Just joking. Awesome. Well, appreciate you, everyone, answering that poll, and it's congratulations, Craig, on the win there. So
Thank you.
all right. Well, if you lead a water utility, again, holiday season, we, thankful for many things. We want to thank you. Because of your hard work and dedication to excellence, we have immediate access to clean, safe drinking water that is both readily available and very affordable. The World Health Organization and UNICEF claim that approximately 800 million people around the world do not have access to safe drinking water whatsoever, and another 1.2 billion lack access to safely managed drinking water at their homes. So you can see that we are truly blessed to have you. We also know that you are very busy and understaffed. You have multiple federal, state, and local regulations that must be followed and documented daily. You have multiple personnel issues that must be addressed, and then there are those customer challenges, line breaks, and budget meetings as well. With all those demands placed upon you, who possibly could have time for an AWWA water audit? Well, many years ago, I knew an older woman who told me that she never bothered to balance her checkbook because it was too difficult and it took too much time. Stunned at this revelation, I asked her how she kept from being overdrawn on her account, and she replied that she simply deposited $200 into the account every 2 weeks, and that just somehow knew that it would cover her expenses. I would have bet $200 of my own money that she'd been charged an overdraft fee at some point over the years, even if she didn't know it. But we never got to the point in the conversation where we started getting bank account statements out. So thankfully, if you do choose not to balance your bank accounts, however, you do run the risk of being overdrawn someday, and that same principle can be applied to a water utility. If you don't compile an accurate water audit every year, you do not truly know how well your utility is operating, and you risk overlooking areas for critical improvements, which may lead to major issues in the future. In 2014, we started working with a small utility in Texas that wanted to upgrade from a manual meter reading system to a mobile AMR system. In order to better understand how this utility was being operated, we obtained a copy of their most recent water audit. And as a brief aside, for anyone who may not be familiar with the AWWA water audit tool, it is a free, easy to use tool. They actually just released a version 6 within the last couple of years. So to download your free copy of the tool, simply visit the American Water Works Association website at awwa.org and search water audit tool, or if you'd like a more personal touch, we've got a copy or two hanging around. So send us an email at bluewater@jci.com, and we'd be happy to send you a copy and show you how to use the tool. So back to our story. In Texas, water utilities with fewer than 3,300 connections are required to submit a water audit to the state once every 5 years. While we all acknowledge that a single water audit once every 5 years may not be the best approach, it is certainly better than having no requirements at all for a water audit. Thus, at the time we worked with this utility, the 2010 water audit was the most current version at the time. So let's take a few minutes to review what we found in this water audit. Again, this was submitted to the state. So the first thing that we noticed was that the production meter accuracy was 100%. Which was interesting because we knew that the production meters had never been tested or calibrated since they were shipped from the factory, which was many years earlier, and the utility had no actual knowledge of the accuracy of those water meters as a result. Although most every meter manufacturer in the United States makes a very fine and highly accurate meter, absolute perfection is all but impossible to maintain in the long term. As such, we strongly recommend every water utility to test and calibrate their production meters at least annually, if not every 6 months. The AWWA water audit specifically uses a top-down approach. So if the volume of water that you input into your system is incorrect, the rest of the water audit and the KPIs will also have issues with them. Something else that we noticed is that this utility had a total authorized consumption of about 15 million gallons more than what they had produced, which is a pretty remarkable achievement. The billed metered consumption itself exceeded the total system input volume by about 5 million gallons. Now, in the utility's defense, they admittedly did not have a tremendous level of confidence in these numbers, and that sentiment was reflected in the data validity score at the right side of the page, where a score of 1 is not confident and a score of 10 is extremely confident. Continuing on with our review of the water audit, we saw something that we've never seen before, a water utility with no water loss. That is to be expected, however, when you sell 15 million gallons more water than you produce. It does conflict with another input, however, and if you see the 98% meter accuracy metric that was input by the utility. Although 98% accuracy is just slightly below the AWWA M6 manual's new meter minimum accuracy standard, it's difficult to have no water loss while also admitting that you're not registering all the water that's being used in the system. Another red flag. And keep that 98% value in the back of your head as we move forward through the webinar, by the way, as it's going to become very important later on in our case study. The last thing that we noticed is that this utility claimed that there were no systemic data handling discrepancies, i.e. things like mixing digits around when you take a meter read, which is remarkable given that the utility had a manual meter reading and billing process. So once a month in this utility, the meter readers would manually read each water meter and then manually enter each of those readings into a journal. That journal was then given to the billing department, who would then manually subtract the current register reading from the previous register reading in order to calculate the billed usage for that billing cycle. Given the level of human input into the billing process, it's more than reasonable to expect that some errors would occur from time to time because we're all human and we all make mistakes. But again, to the utility's credit, their data validity scores continued to remain extremely low as they entered this data into the audit. The Texas Water Development Board uses a slightly modified version of the AWWA audit, so we took the liberty of importing that data submitted to the state into the then current version of the water audit tool from AWWA for the purposes of evaluating the key performance indicators. The non-revenue water as a percent by volume of water supplied, i.e. water loss percentage, here you hear a lot of people refer to their water loss percentage, was a negative 1.5%. And the infrastructure leakage index value, which is a ratio of current annual losses to a theoretical limit of unavoidable annual real losses, was a negative 0.88, something that is impossible to achieve in the physical universe that we occupy. Just for reference, a world-class utility still leaks between 2 to 5%, and most states, if they have a goal for percent non-revenue water, they usually encourage 10% or less. So I'm going to hand it over to Craig in a few minutes to continue the story, but before I do, here's a brief recap of some key points for you to remember from this 2010 water audit worksheet. The first is that the production meters were 100% accurate. Second is the billed meter consumption exceeded the total system input volume, and the utility sold 5 million gallons more of water than it input into or produced into the distribution system. Number three, the total total authorized consumption exceeded the total system input volume by about 15 million gallons. Number four, customer metering accuracy was 98%. Number five, there were no systemic data handling issues, even though both the meter reading and billing process were performed manually. And then lastly, the very low grades on the data validity score showed that this utility had very low confidence in the accuracy of the data. All right, as you're committing those snippets from the AWWA water audit to your memories, let's pause for a quick survey. So according to bestlifeonline.com, so this is their list, not ours, so if there's a song on here you like, it's not us, blame them. But the 5 worst Christmas songs of all time are: 1, The Christmas Shoes by New Song; 2, Wonderful Christmas Time by Paul McCartney; 3, Do They Know It's Christmas by Band-Aid; 4, The Chipmunk Song by Alvin and the Chipmunks; and 5, Dominic the Donkey by Lou Monte. Do you agree? And if so, which of these 5 songs would you prefer never to hear again? Hopefully you're seeing that come up. Yeah, we got some responses coming in.
Yeah, Jonathan, your mom can't vote on this one. Sorry.
No, she can't. She can't. She would, if she watches this recording, she's gonna slap me because there's one of these songs.
I know it.
Yeah. All right, 56% in.
All right, it looks like Dominic the Donkey, and I gotta agree. That's that's a song that'll make your ears bleed.
I still got to go back and listen to that one, Craig, or maybe I don't. I guess if it won
Yeah,
amongst the crowd, maybe I shouldn't.
I'd skip that.
All right. Well, thank you all for your responses. And I guess with that, Craig, I'm going to hand over to you. Would you mind walking us through what you found during our detailed engineering study with this customer?
Yeah, I'd be glad to, Jonathan. 4 years later, this utility decided that the time had come for new water meters, a mobile AMR system, and to make some much needed improvements to the water treatment plant. The utility just didn't have and could not obtain the funds it needed to purchase these items outright, so they turned to performance contracting as an alternative funding source. In a performance contract, the efficiencies gained by installing new technologies are used to pay for the project over time. Moreover, if the guaranteed benefits are not being realized by the utility, the company offering the performance contract must financially cover the shortfall. The fundamental challenge in a performance contract is to determine an accurate baseline. And without an accurate baseline, it is impossible to calculate the benefits to be realized from implementing water loss optimization measures, such as installing new, accurate water meters, water meter sizing and typing, installing an AMR or AMI system, and many, many others. So once the detailed engineering study commenced, we discovered that the overall weighted average accuracy of the 5/8" water meters was not 98%, but 80.4%. Yes, you heard me correct, 80.4%. Now, here at Johnson Controls, we like to be extremely confident in our revenue projections for your utility because, as I pointed out on the last slide, your cash flow and our reputation depend upon it. And as such, we make sure that our baselines utilize a 95% confidence interval in our statistical analysis of water meter accuracy. What this means is that sometimes we're forced to remove data points which are considered to be outliers, even if the removal hurts our business case. And in this case, there were a handful of outliers in our data set for this project, so we ended up using an accuracy of 86.6% for the 5/8" water meter population in our business case. But in financial terms, the inaccurate 5/8" meters were costing the water utility an estimated $92,600 in unbilled water and sewer revenue over the course of 1 year. And let's talk about large water meters. If the large water meters are set in outside vaults, I can normally survey around 20 settings a day in good weather. And even though there were only 14 large water meters in this utility, it took us several days to complete the survey because many of the settings were completely buried and required excavation. The largest water meter in the utility was a 6" compound that served a detention center, and it was installed vertically, as you can see in the photo. A compound meter consists of 3 main parts: a small disc meter measuring chamber assembly to measure usage at low flow rates, a large turbine meter measuring chamber assembly to measure usage at both intermediate and high flow rates, and a crossover valve assembly to prevent the flow from entering the turbine meter chamber at low flow rates. A compound meter should never be installed vertically because the check valve assembly that opens the turbine meter measuring chamber to the flow is literally fighting against gravity to remain closed. This compound meter will most likely be inaccurate at low flow rates, and the crossover valve bearings will wear out quickly. We also discovered that 4 of the 14 large water meters were completely dead and registered no usage whatsoever. The bypass measuring chamber assemblies on 5 other compound meters were completely clogged with debris and could not register any usage at low flow rates, which means that at best, these meters were only 33% accurate. Overall, only 4 of the large water meters tested accurately. Now, in addition to the dead and highly inaccurate large water meters, we discovered some other remarkable things, such as 31 out of a total of 40 2" water meters were simply not being billed at all, not even for the monthly base water and sewer charges, because these 2-inch water meters were either dead and registered no usage, or they were completely buried and could not be read. We found the utility billing system itself was in complete disarray. Nearly half of the accounts had at least 1 month out of the last 12 months with no billed usage. And this utility was neither a resort area nor a transient community that would help to explain those missing months. The average account had at least 4 months out of the last 12 months with no billed usage. In essence, the average customer of this utility paid only 2/3 of their water and sewer bills for the year. Moreover, just over 13% of the records contained no meter size data, which is necessary for determining base charges, and nearly 6% of the records had conflicting meter sizes in the data. These customers are paying monthly base charges for water according to one size of water meter, and then paying monthly base charges for sewer at a different size of water meter. And lastly, there were 68 active accounts that only had an account number and a service address with no other billing information included in the record. So our scope of work for this utility included a total water meter replacement, and while we normally recommend leaving accurate water meters in service, those 4 large water meters that tested accurately, well, those were obsolete and we couldn't get encoder registers for those meters, so they had to be replaced. We installed a mobile AMR system to read both the water meters and the natural gas meters, and not only did this eliminate the human errors in the meter reading and billing processes, but it greatly increased staff efficiency. Obviously, the utility billing system received a complete refresh, if you will, so that each account holder would be billed correctly each month. Now, I will say to their credit, large water meter typing was unnecessary for this customer because they had the correct type of water meter installed at each service. We couldn't determine the benefits from 2-inch water meter typing because, as we talked about before, 80% of the large meters, 80% of the 2-inch meters were either buried or dead, which made it impossible for us to create a baseline. And there were many other measures that we could have implemented to reduce both the real and apparent water loss, but this customer just wasn't interested in those. So now I'm going to ask Audrey to tell us about the installation phase of this project and some of the very unusual conditions that we encountered during the installation phase. Audrey?
Well, project installation commenced in early 2015. A combination of people moving away, businesses closing, and cleaning up the utility billing system created some noteworthy changes. The total number of 3/4-inch meter accounts decreased 4%, and more importantly, the city lost 5 large water meter accounts, which is a decrease of 23%. Losing nearly a quarter of your large meter accounts could have a devastating effect on most water utilities. The city had nearly 15 inches of rain in our base year, but that part of Texas experienced significant flooding, and this city received 22.5 inches of rain in 2015. This 7.5 additional inches of rain was a 50% increase over the base year, which was from July 2013 through June 2014. In summary, the city did not change the water and sewer rate structure after the project was installed, so no increase in billable water and sewer revenue could be attributed to increased rates. The total number of active accounts decreased 3.7% from the base year, and that included a 23% decrease in the number of large water meter accounts. So both billable usage and billable revenue should have decreased accordingly. The 50% increase in precipitation also should have contributed to a significant decrease in billable usage and billable water revenue. So given all those challenges, let's see how the water meter, mobile AMR system, and billing system refresh affected this utility. Was our project successful? The total billed usage during the base year period of July 2013 through June 2014 was 424.2 billion gallons. We commenced installation in November 2014, and billable usage over the next 12 months increased 660% 72.1 billion gallons, which is an increase of 247.9 billion gallons, or an unbelievable 58.43%. Billed usage for the 1-inch meter population alone increased 54%, and billed usage for the 1.5-inch meter population increased over 2,000%. Given that the city lost 5 out of 14 large water meter accounts, the decrease in billed usage for the 4-inch and 6-inch meter sizes was to be expected. So we looked at the billed usage on the last slide, and let's look at billed water and sewer revenue on this slide. The water revenue is in the blue table at the left, and the sewer revenue is in the brown table at the right. Remembering that there was no increase in either water or sewer rates after project installation started, the billed water revenue increased by $185,000, or nearly 15%. The billed sewer revenue increased by $106,000, or 26.6%. Was this project a success? Despite the 3.7% decrease in the total number of active accounts, the 23% decrease in the total number of large water meter accounts, and the 50% increase in precipitation, there was a 58% increase in billed water usage and nearly a 15% increase in billed water revenue. There was also a 26.6% increase in billable sewer revenue, and the total billed water and sewer revenue increased by 17.65% from the base year. I would have to say the project was truly a success in decreasing apparent water loss, increasing billable water usage, and therefore billable water and sewer revenue, and increasing staff efficiency through the automated meter reading and billing process. We also restored equity throughout the community because every account holder was now paying for the water that they used. Jonathan, you compile AWWA water audits on a regular basis. And you know it takes some time and effort to compile an accurate water audit, so I must ask your opinion. Given this case study from one of our customers, what are your thoughts on the value of AWWA water audits?
Well, Audrey, like anything in life, you get out exactly what you put in, right? And so if you make the time and effort to compile an accurate AWWA water audit, you'll have a realistic image of how your water utility has performed over the last year. And more importantly, you'll know what areas of your distribution system need attention. You'll also have an idea of the financial impact that those areas are having upon your utility so that you can better justify investments to your board or councils. Unfortunately for our small utility, they were simply not able to attain the level of detail that was necessary to show how a combination of inaccurate meters, an error-laden billing system, poor meter reading practices, and poor meter maintenance combined to cost them almost $291,000 a year in unbilled water and sewer revenue. And for a small utility with 3,000 connections, that's a tremendous amount of unbilled water and sewer revenue to be losing every year. And that begs the question, what could they have accomplished with that unbilled revenue over the last year? Furthermore, if you extrapolate that lost revenue back to 2010 when that original audit was submitted to the state, you could make the argument that that total would be north of 1.4 million in unbilled water and sewer revenue. What could they have done with that? Well, hopefully we've shown that the importance of compiling an accurate AWWA water audit should be number one on your list. If you're concerned about water loss, unbilled revenue, and reducing both operational and maintenance expenditures, please reach out to us at bluewater@jci.com or submit a question in the Q&A. If you do have any questions about anything other than what to get your spouse or significant other for the holidays, then please also submit those in the Q&A module on your screen. If you're like Craig or I, however, and you just don't think of a question until several hours or even days after an event has ended, again, our email is bluewater@jci.com. We'd love to hear from you, and we'd be happy to help you in any way that we can. So with that, let's see what we have here. Any
We have
questions?
a poll question.
Right. Are there any Q&A, Craig?
Not yet. I think we're ready for our poll question.
Okay. All right. We'll move on. Like I said, either Q&A or bluewater@jci.com. Let us know. All right. So before I turn the presentation back over to Craig to introduce our special guest from GoAigua, we'd like to take one more poll, and our question is, does your utility compile a water audit? And you can say, yes, you do one annually, you do, but it's not annually, or no, you don't compile one, or maybe you just prefer not to answer. So.
Yeah, we will not report you to AWWA, we promise.
You won't get any mystery emails with free audits or any of that coming in your mail. All right. Looks like we got about half of the full. There we go. Still got a couple coming in here.
All right, well, I'm gonna go ahead and close the poll.
Yep. All right, a little over half looks like they do one annually.
Very well done, well done.
Yep, excellent.
I think we scared them, maybe.
Maybe, I don't know. You know, I didn't say it earlier, but usually when we talk about water audits and I'm, you know, have the opportunity to be live somewhere, I always ask for a show of hands of who's familiar with the tool, who has used it, and it's usually less than 50% of the hands go up, even after I jar the group a couple times. So the fact that we're over half with this crew is a great thing.
Yeah, well done.
All right, Craig, I'm handing it over to you.
All right. Okay. If you'll advance the slide, there we go. All right, well, thank you, Jonathan and Audrey. And joining us today are TJ Butler, the Director of Business Development for GoAigua, and Marcy Rather, who is a Regional Business Development Manager at GoAigua. TJ, would you please tell us a little bit more about yourself and what you do for GoAigua?
Thanks, Craig. Yeah, and thanks for having us. Yeah, like you said, my name is TJ Butler. I'm with GoAigua. I've been here for about 2 to 3 years now, and we are a software and analytics company for water and wastewater, and we're just my role here, along with Marcy's, we go out and try to share innovative ways to become more digital at your utility. And I'll pass it back to you and Marcy.
All right, Marcy, would you please tell us a little bit about yourself and your background in water and what you do for GoAigua?
Certainly. Thank you, Craig. My name is Marcy Rather. I transitioned into the water industry nearly 10 years ago. I have primarily worked within the metering world over the last couple of years in building AMI proposals. I worked ardently towards differentiating our proposals from everyone else. And in my search, I came across the solution of GoAigua. Having had a previous relationship with TJ, we began working together, and because of my understandings of the importance and value of GoAigua and what it provides for the utility systems, as soon as there was an opportunity, I quickly joined the team. Very happy to be here today. Thank you.
Well, excellent. We're so glad that you could join us. And TJ, would you please tell us more about GoAigua and how water utilities can benefit from this amazing platform that you have available?
For sure. I'd like to take the screen over if I can here.
Okay.
Can you see my screen?
Yes.
Yes.
Cool. So, yeah, thanks again, Craig. Those are really impressive results that you showed. I think it's really important, the AWA water loss audit, and we can talk a little bit about how we transition those kind of reportings with GoAigua as well. So, again, GoAigua, we're a software analytics company for water and wastewater utilities. And before I get into our story and where our company came to be, I just wanted to talk a little bit about the industry of smart water and digital water, and how really the problems that some utilities are facing globally are attributing to becoming more digital. So I just want to share this 5-step framework that from the Smart Water Network Forum called SWAN. So the way they highlight digital water is they look at these 3 steps: the physical layer, your pipes, your valves, the sensing and control, your meters, what's reading that technology. You talked about AMR from your previous client, Craig, but also collection and communication. how are we obtaining that data? Is it a drive-by-MR system? Is it a fixed network AMI system? So those are our three first steps here. And where GoAigua fits in the industry today is when we come in 4 and 5, and that's data management and display and data fusion and analysis. So how can we bring that data together, display it for a customer so it's easy to read and understand what's happening in your system, but then how can we mold that data together to make smarter decisions, whether that's bringing in data from different sources, applying machine learning, and displaying that in an easy to understand dashboard. So you as a utility staff member can go in to your office on Monday morning and see exactly what's going on, either from your office or out in the field. So why do we have steps 4 and 5 here? So the benefits of being able to more efficiently manage your data is operational improvements. One, the financial benefits of increased revenues, looking at water loss, for example, resiliency. How can you put all your data together to run simulations to see how your network is going to be affected on different conditions? And then benefits to the community, because ultimately that's what we're here, providing clean water for all your communities that you're operating in your service area. So that's the framework. And then what kind of challenges are utilities facing that we're seeing is that there's a lot of time. You talked about that AWJ water loss audit. There's a lot of time that utilities need to take on reporting. So, and to really put these reports together, there becomes a problem that all of your data sources are siloed in different platforms, different information, but they're also in different formats. So it's tough to compare. Then also relying on that sensor data and being able to do some QA, QC on data to make sure that the integrity of the data that's coming into your solutions are correct. And we are heavily reliant on these sensors to bring us accurate data. So we want to make sure that we're doing that QA, QC. So those are some of the challenges facing utilities. And then at the center of all of these challenges is your water operator. So we're generating a huge amount of data, but how do we use it? We're investing in new technology, which is making us acquire more and more data points. And there's an explosion of software solutions. Each one of my applications for all of my sensors have a different platform that's feeding different data. And also in a lot of cases in water utilities, that the IT departments are small, they're getting dragged into different departments. So it's hard to go to your IT department to develop certain solutions that may help you as a water operator. So now those are some of that's really where digital water is in the industry and some of the problems utilities are facing. So how does GoAigua come into play? So GoAigua was born out of Global Omnium. Global Omnium, we operate a private utility in Europe. We manage over 400 cities, including the city of Valencia. The city of Valencia is one of the first utilities to do a full AMI deployment back in the early 2000s, and also the first utilities to really have a fully operating digital twin, which I can get into a little further in the presentation. So what did we face at Global Omnium as a utility ourselves? We went out to market to look for a solution that was going to bring all of our data together to automate a lot of processes and really democratize the data through different departments. So different departments have value with different data, and we want to make sure that everyone has access to that. So these silos were broken down from SCADA, GIS, and there's also a generational gap that we saw as a utility. There was senior operators with a ton of knowledge around all of the water and sewer systems that were leaving the utility, and we really did not want that knowledge to be lost in this process. So if you put together a senior operator with a digital native that understands data and understands data science, and through that process of retaining that knowledge, we put it into our platform called GoAigua. So GoAigua is a software platform for water and wastewater utilities again, and we operate as a software and analytics company here in North America. So that is our story. That's where we came to be. You'll see that a lot of our solutions are practical because they're they're coming from a utility with a specific use case and a specific problem that we're trying to solve with the software applications that we have for utilities. And another problem I mentioned a little bit before is that as utilities are investing in new data acquisition sources, so you have your GIS, your SCADAs, there's what correlates with the volume of data generated with all of these new investments is a challenge of data management. So once you go with a full AMI deployment or AMR deployment, there's millions and millions of data points you have to manage as a utility, and it becomes really impossible to do that with your different sources and different silos of data. So that's where we come in. And right now we operate in North America. We work with some of the largest utilities out there, like Mexico City, the city of Houston, city of Toronto, but also we work with really small utilities, and we take pride in being a solution provider that has a solution for some of the biggest utilities, but also some of the smaller utilities as well. We have customers that are servicing as low as 3,000 connections. So our general architecture of our platform and our solution is that the foundation of our company and our solution is data integration. So you can see a lot of different technologies that you might be used to, or some of the utilities on the webinar here might be using some of these technologies. So from all these different technologies, whether it's your AMI, your sensors, your SCADAs, we build that into a single data model. And within that single data model, you host all of your real-time and historical data from all of your different sources, so you can start combining different data sources. So for example, the AWA water loss report, you want to be able to take a lot of production and SCADA data and compare that with customer data, so you can see what you're producing versus what is finally getting billed to the customer. So that's just one of the examples. So from this single data model, we are applying different modules that kind of go at and attack that data model to provide a solution. So that solution is non-revenue water, energy optimization, doing some meter analytics, some predictive pressure monitoring, and also our digital twin, which is essentially a real-time environment that is a digital replica of your distribution system and your sewer system. So from our platform here, and correlating with the SWAN framework of you have your sensing and your control all the way up to your data management and then your data fusion and analysis. So what does that look like from our standpoint? We look at that in 5 steps. So steps 1 and 2 is building that data core, being agnostic to the technology that's feeding the data model, and then applying some operational data integration, getting your GIS integrated with SCADA, automating some reports, and democratizing that data for different departments to use in really any way they want. So in the platform, really what it looks like is, okay, first we can get a geographic representation of our data historically in real time, integrated with SCADA and really any kind of sensor that you have in a field. It's really simple, but it's also something that can really be helpful for utilities to understand where's my data coming from and how can I visualize that with my GIS, which is a really foundation. The GIS is really the foundation for utilities. So from the GIS, we're looking at real-time reporting and advanced analytics, being able to see what exactly is happening throughout your operation. So you're seeing some pictures integrated with live data, some basic operational monitoring, but then we also go into some more dashboarding and analytics that can be really helpful for utilities. So for example, this utility, they wanted to see a holistic view of their well production to treatment plant production to really optimize their water production sources, and then the cost associated with getting water from these sources, whether they're purchasing or generating this water themselves. Then we also bring in some operational data from the wells, from the pump stations, lift stations on the sewer side of things, to really get a grasp on what's happening at your utility. And then going back to some reporting. So it takes a lot of time to generate these reports, but if you have a single data model, you can start tagging live data sets and historical data sets to compliance reports that you have to do on a monthly, annual basis. And this can free up a lot of staff time by being able to take all of your live data and generate automated reports with that data. Now, as I go into step 3 and 4, the more data we have, the more things that we can do with it. So Craig was talking about the water loss audit, and we have a way of taking the data assumptions that AWWA uses in their water loss audit and then automating that connection between the SCADA system, the metering system, and the billing system to be able to automate what is comparable to the AWWA water loss audit. So this frees up a lot of time, being able to get this report from just a click of a button rather than doing it annually. And then bringing in some more AMI data with tagging that to the GIS, having a heat map of consumption, 40+ alarms based on data science and historical series. And then another thing that is getting more and more popular in the industry is the idea of DMAs or virtual DMAs. So how can we break up our service areas to visualize data, to understand our water loss as a whole, as a utility, as a city, as a town, but also how can we break up our city or town to be able to identify where there are areas of problems with water loss. So by really visualizing this and whether that's deploying insertion meters at certain points of your system, you can start analyzing your production going into a certain area along with your billed consumption, so you can start sending your crews out to specific areas where you know there's potential water loss. And then even at tying in those acoustic monitoring, there's really great technologies out there. Again, we're agnostic to the data that we're bringing in, but there's a lot of great technologies that can really help pinpoint leaks. So we also want to use that data and really go from pinpointing water loss to an area to a specific point in your system. And then we can optimize. We want to take some data from pumping and energy costs. So we can essentially look at night pressure and day pressure and optimize the pumping schedules, but also take into effect the rates that we're getting on energy that we're using, so we can change and optimize pumping schedules based on those rates to start saving energy costs. And then quickly, I'll go into step 4 and 5 as I finish and pass it over to Craig here. But by applying all this live data to a single data model and taking all this historical data, we're actually able to start integrating all of this data with your hydraulic model to essentially get a dynamic model where you can simulate real-time pressures and flows through your entire distribution system. So you can go back in the past to see what might have happened in a certain emergency or a main break. You can simulate a main break in the present, and you also can simulate an event happening in the future. So this is really helpful for scenario planning for utilities to understand what certain events are going to have, what effects are these events going to have on my system. And then the same thing with wet weather management and on the stormwater and looking at flooding. So by taking all of your live data from your system here, we can integrate weather data and forecast data to simulate what's going to happen during certain rain events and simulate where I could probably direct the flow of water so I don't get flooding in certain areas that could cause a problem to the public and public health. But yeah, that's what I wanted to get through today. Again, we're GoAigua, we're a software and analytics company, and I appreciate JCI bringing us on today. And as you can see, JCI is a great organization doing some great stuff exclusively with some water loss. But I'll pass it over to you, Craig, to finish up here.
All right. Well, thank you, TJ. You did a phenomenal job, and I think you explained digital twins better than anybody I've ever heard before. So I appreciate that. And right now, do you have time for some questions from the audience? If you're in the audience and you'd like to ask a question of Marcy or TJ, please use the question module on your console. And they'll be happy to take questions. And if you think of a question later that you'd like to ask, just send us an email at bluewater@jci.com, and we will be very happy to get with TJ and Marcy and get your question answered promptly. Okay, and now I'd like to turn the presentation over to Audrey to tell us what's coming next in the new year.
Thanks, Craig. Well, please join us for the next Johnson Controls Blue Water webinar on Wednesday, January 18th at 11 a.m. Eastern Time, 8 a.m. Pacific Time. We have another remarkable case study for you next month. We took best practices and newest technologies for water utilities and used them to reduce water usage by over 50% at a correctional center. Cameron Keys and Eric Galassi from Guterman will join us to talk about real water loss reduction that can be achieved through ZoneScan NB IoT correlating leak noise logger. You can register for this free webinar by using the link that you see on the slide, capturing the QR code on the slide with your smartphone, or send us an email at bluewater@jci.com and we'll email the registration link right to you. Very special thank you to TJ Butler and Marcy Rather from GoAigua. We want to remind you to please invite your friends and colleagues to attend the Blue Water webinars and to please submit any topics you want us to cover in future webinars. We want to know what's important to you and your utility. You can contact us at bluewater@jci.com. Thank you for attending the Johnson Controls Blue Water webinar today. We want to wish all of you a very happy and safe holidays, and we look forward to seeing you again on January 18th.
All right.
Thank you.
Well, thank you and happy holidays.